Welcome back, everyone. We are up to lesson 14 of Unit 4. And in this particular lesson, we're going to learn how to solve exponential equations using logarithms. Now, before we get into exponential equations, I want to first talk about a couple of special logarithms that you might see moving forward. I know I had mentioned this in a previous lesson, but in case you forgot, whenever you see log with no base, okay, log with no base really means log base 10. So, for example, log of 10 means log base 10 of 10. Log of 15 means log base 10 of 15, so on and so forth. So, log with no base means log base 10, okay? And then there's another special logarithm that we use when the base is e. So whenever I have log base e, okay, you might see this right here, ln. ln stands for natural log. ln means natural log, and that means log base e. So again, if you ever see ln, that means natural log or log base e. Okay, it's not any harder than a normal logarithm. It's just a different notation we use for that specific scenario of log base e. With that in mind, when we're solving exponential equations, okay, the first thing we're going to do is we're going to isolate the term that contains the exponent. That's the first thing we do. So we always do the opposites whenever we want to get rid of something, okay? Once I have isolated the term with the exponent, I can rewrite the equation in logarithm form. So rewrite the equation in log form, and then, if necessary, solve for x. So I have a lot of examples that I want to go through with you in this lesson. So let's start with number 1. Okay, so I have 10 to the power of x equals 10,000. Okay, the first step is to isolate the term that has the exponent. Well, in this case, the term is already isolated. So I can do the next step, which is to rewrite the equation in log form. So this is going to be log base 10 of 10,000 equals x. So in other words, x equals log base 10 of 10,000. Okay? And we should be able to figure that out. So 10 to what power is equal to 10,000? 10 to what power is equal to 10,000? That's going to be 10 to the power of 4. So in this case, x is going to equal 4. Okay, and that's really it. Okay, number 2, we have 5 times 10 to the power of x equals 500. Okay, step 1 again is to isolate the term with the exponent. So I need to isolate this right here. Okay, so in order to do that, I need to get rid of the 5. Well, how am I going to do that? Well, since the 5 is being multiplied, I get rid of multiplication by dividing. So I'm going to start off by dividing both sides by 5. So that gives me 10 to the power of x equals 500 divided by 5. 500 divided by 5 is 100. Okay, 500 divided by 5 is 100. Now I can rewrite this in logarithm form. So this is going to be log base 10 of 100 equals x. So x equals log base 10 of 100. And log base 10 of 100, we should know that log base 10 of 100 is equal to 2, because 10 squared is equal to 100. So this is my answer to number 2. Okay. Number 3, we have 10 to the power of x plus 3 equals 10,000. Okay. My term with the exponent is already isolated, so I can rewrite it in log form. This is going to be a little different because in log form, this is going to be log base 10 of 10,000 equals, my exponent is x plus 3. So I can reverse that order and make it x plus 3 equals log base 10 of 10,000. And we should know, we figured this out at number 1, that log base 10 of 10,000 is equal to 4. So what I'm really solving is x plus 3 is equal to 4. So I can solve that by subtracting 3 from both sides. And I end up with x equals 4 minus 3, which is 1. So for number 3, the answer is x equals 1. Okay. So that's number 3. Let's go to number 4 now. Okay. 10 to the power of 2x equals 10,000. Okay. Again, my term with the exponent is isolated, so I could rewrite this in log form. So this is going to be log base 10 of 10,000 is equal to 2x, since that's the exponent. So 2x equals log base 10 of 10,000. Okay. And now I'm going to solve for x. But before I do that, actually, I should know that log base 10 of 10,000 is equal to 4. All right, we did that. We've done that one before. So I can finish this off by dividing both sides by 2. So x equals 4 divided by 2. So x equals 2. All right. Okay, number 5. Number 5 is 10 to the power of x equals 315. Okay, my exponential term is isolated. There's nothing I need to get rid of, so I'm going to rewrite this in log form. So this is going to be log base 10 of 315 equals x. So x equals log base 10 of 315. Okay. In this case, I'm going to leave it in log form because I should know that log base 10 of 315 is going to be a decimal. There is no whole number power that I could raise 10 to and get an answer of 315. That's going to be a decimal. So similar to when I decide to leave my answer as a fraction, when I know the answer is going to be a decimal, I'm going to leave this in log form. So I'm going to say that x equals log base 10 of 315. Okay. I should mention that if we go back to our lesson notes for a second, okay, remember log with no base is assumed to be log base 10. So if I wrote my answer as this, if I just wrote log 315, that would also be correct because log 315 means log base 10 of 315. So either one of these, if this were a quiz, either one of these would be acceptable, would be considered correct. Okay. We are up to number 6 now. 2 times 10 to the power of x equals 800. Okay. This time I actually do have to isolate the exponential term. So to do that, I'm going to have to get rid of the 2 by dividing both sides by 2. So I'm going to start off dividing both sides by 2. That gives me 10 to the power of x equals 800 divided by 2, which is 400. Now I'm going to write it in log form. So this will be log base 10 of 400 equals x. So x equals log base 10 of 400. Once again, log base 10 of 400, I'm going to leave it in log form because the answer is going to be a decimal. There's no way I could do 10 to some whole number power and get an answer of 400. So this is definitely going to be a decimal. So I'm going to just say x equals log base 10 of 400. Or, again, since the base is 10, I could say x equals log 400. It means the exact same thing. So I can say either one of those two things, and that would be considered correct. That would be considered a correct answer. All right. So that's number 6. Let's take a look at number 7 now. So number 7 is 10 to the power of 1.2x equals 4,000. 10 to the power of 1.2x equals 4,000. I don't need to isolate the exponential term because it's already isolated. So in log form, this is going to be log base 10 of 4,000 equals 1.2x. All right, or 1.2x equals log base 10 of 4,000. Okay, so now I have to solve for x. Okay, if I look at this log base 10 of 4,000, is that going to be a whole number or a decimal? We should know that this is going to be a decimal. There's no way I could raise 10 to a power and get an answer of 4,000. So I'm going to leave this in log form again. So to finish this off, to solve for x, I'm going to just divide both sides by 1.2. So x is going to equal log base 10 of 4,000 over 1.2. Okay. Or I could say x equals log 4,000 divided by 1.2. Again, if the base is 10, I don't necessarily need to write base 10. So either one of these would be considered correct. All right. We are up to number 8 now. So number 8 is 7 times 10 to the power of 0.5x equals 70. Okay. For this one, I do have to isolate my exponential term. So I'm going to do that by dividing both sides by 7. Okay. So I end up with 10 to the power of 0.5x equals 70 divided by 7. 70 divided by 7 is 10. Now I'm going to rewrite it in log form. So this is going to be log base 10 of 10 equals 0.5x, or 0.5x equals log base 10 of 10. Now in this case, this is definitely a whole number. Log base 10 of 10 means 10 to what power is 10? This is going to be equal to 1. Why? Because 10 to the power of 1 is 10. So this gives me 0.5x equals 1. So I'll finish it off by dividing both sides by 0.5. So x is going to equal 1 divided by 0.5. 1 divided by 0.5 is equal to 2. Okay? 1 divided by 0.5 is equal to 2. So x in this case is equal to 2. Okay? So that's number 8. All right, number 9. Okay. 2 times e to the power of x equals 16. Okay, so notice this time my base is e. All right, that's not going to affect how we solve the problem. So I'm going to start off by dividing both sides by 2. Okay, so I'm going to have e to the power of x equals 8. Now I'm going to rewrite it in log form. So this will be log base e of 8 equals x, or x equals log base e of 8. This is definitely going to be a decimal, so I'm going to leave it in log form. So I'm just going to say x equals log base e of 8. Now, if we go back to our lesson notes, remember, one of our special logarithms, if we have log base e, we can use ln, or natural log. So I could technically write this answer as x equals ln 8. X equals natural log of 8. It literally means the exact same thing. Natural log of 8 means log base e of 8. So again, if this were a test or a quiz and you wrote either one of these as your answer, you would get full credit. It would be considered correct. Okay? So lastly, number 10, we have 10 times e to the power of 3x equals 250. Okay. So once again, I do have to isolate my exponential term here. So I'm going to start off by dividing both sides by 10. So that gives me e to the power of 3x equals 250 divided by 10 is going to be 25. Again, I'll rewrite this in log form. So this will be log base e of 25 equals 3x. So 3x equals log base e of 25. Now I'm going to solve for x. So I'm going to divide both sides by 3. So I get an answer of x equals log base e of 25 divided by 3. Okay. Or, so that's the answer. Or I could write it as x equals natural log of 25 divided by 3. So again, either one of these would be considered correct. Okay, so log base e of 25 divided by 3, or ln natural log of 25 divided by 3. Either one would be considered correct. Okay, and that is it for today's lesson on solving exponential equations.